Hello and welcome. Today we're doing the Leaving Cert 2020 Ordinary Level Question 1. This is a financial maths question. Let's get started. A television costs €380 before VAT at 21%. Find the cost of television after the VAT has been added. So we need to get 1%. To get 1%, we will divide by 100, then we will multiply by 121 to get the final amount when VAT has been added. The final result being €459.80. Part B, you can see we have 21% is the price of the laptop increase. So we can equate the 21 with the increase. Again, we want to find the final amount. So we need to divide by the percentage, which is 21, and multiply by 121 to get back to a total of €750.20. Finally, a printer is priced at €290.40, including VAT. This means that we have at the moment 121%. Again, let's return to the fundamental 1% by dividing by 121. When we know what we have, it's very easy to find the amount required. We have 1%. In this case, we only need the VAT amount, so that means we need the 21%. Multiply up, and we get. Hello and welcome to Maths Plus. This is the Part D of 2021, Question 1, Ordinary Level Leaving Cert. Here we have a financial question. The standard rate of VAT in Ireland was reduced from 23% to 21%. A company bought 30 computers. The reduction in cost was €336. This means that 2% will be equivalent to the €336. What we need to find is the price of one computer. Therefore, we divide by 2, you'll get 1%, multiply up for 100%. This 100% is equivalent to 30 computers. Divide by 30. Hello and welcome to another edition of Maths Plus. Today we'll be covering the 2021 Leaving Cert Ordinary Level Complex Numbers question. First of all, we need to plot Z1, which is equal to minus 3 plus 4i. So to do this, we need to go out to minus 3 and up to plus 4. On to Z2 now, which is out 4 in the real axis and up plus 3 in the y-axis. Now we need to add Z1 plus Z2, write them out fully as such, and now let's separate out the real on the left and the imaginary on the right. You can see that the I value will be the imaginary values. Finally, we get a result for 1 for the total of the real and plus 7i for the total of the imaginary. And let's plot this on the Argand diagram. So go out 1 and up 7, and there you have Z1 plus Z2. Thank you for. Hello, and you are very welcome to another edition of Maths Plus. Here we are going to do a Leaving Cert 2021 Complex Numbers question. We are on to Part B of Question 2. Now we're going to be doing a conjugate rule applied to a fraction. So write your original complex number fraction. Now we're going to multiply above and below by the conjugate of the denominator. When you have a positive and negative of the complex number with the same real and imaginary numbers, this is called conjugate combination. In this case, we need to balance above and below, so we can repeat the complex number above the original one. All we need to do now is multiply everything out. So below, we will get a cancellation of the I values. We can write 4 plus 3i by 4 minus 3i as 4 squared plus 3 squared. This is the conjugate rule applied. Above, with the numerator, we can split and repeat the two brackets. Do this in steps so that you can track all the values. Now we can simplify further. We have 25 below and minus 12 plus 9i plus 16i minus 12i squared above. Please note that the I squared is equal to minus 1. This will make that I squared number a real number, and we can combine it with the real part of the complex number in the end. Now let's write everything together as a result, and we're going to get minus 12 plus 12. This will give us 0 for the real, and plus 9i plus 16i for the imaginary. This will give us a total of 25i all over 25. Divide into both sides, and we get a result of Z3 is equal to 0 plus 1i, or 0 plus I. Thank you for watching Maths Plus. Continuing on the 2021 Ordinary Level Leaving Cert paper, we're on question 2 part C of the complex numbers. Here we need to get the modulus of the conjugate of Z1. You can see the bar over the Z1. And we're going to apply this to a combination. Firstly, we need to look at the modulus formula. Here we have a rectangular form number where we have the real and the imaginary coefficients. These will go into the square root. We square both of them to get the modulus, which is the distance from the origin to the coordinate. For the internal part of the bracket, we need to get the conjugate of the original Z1 value, change the sign in between, and let's substitute this into the modulus lines. Notice that I applied the bracket here around Z2. This is because the complex numbers have two parts and we need to do this in stages. Multiplying by your minus, we get a minus 4 and a minus 3i. Combine these together and you can see we have a minus 7 and we have a minus 7 also for the imaginary coefficient. Let's work out the result. The square root of minus 7 squared plus minus 7 squared is equal to the square root of 98. You can see in the question we need to put it in third form. This means that P will be equal to 7 and Q will be equal to 2. Thank you for joining. Like and subscribe. Thank you. On to question 3 now, and we can see we have a quadratic equation, x squared minus 2x minus 8. We need to show that x is equal to 4 is a solution. This means we need to substitute it in to the equation. If we substitute it in, it will show that the output is 0. Therefore, it's a solution, and that value is on the x-axis. On to part B. The equation x squared plus ax plus b is a quadratic general form equation with two unknowns a and b. We are given two values of x. These are the two roots, and we need to solve for a and b. So in a way, we're working backwards from solving the general equation where we have the answers and we need to form the equation. So let's look at this. X is equal to 5 as a root and x is equal to minus 2 as a root. So they're the values where the quadratic graph crosses the x-axis. If we bring these back and put them into the brackets, we are creating the factors. So in a way, this is a reverse process of finding a solution. Let's split and repeat. And now we can get the equation. Let's compare the coefficients. Ax, therefore a is equal to minus 3, and b is part C now. Find the solutions of the general equation 5x squared minus 2x minus 9 is equal to 0, where x is an element of real numbers. Give your answer correct at 2 decimal places. This means that the solution will need to be found using the minus b formula. Let's get our coefficients. We can see that a is equal to 5, b is equal to minus 2, be careful with the signs, and c is equal to minus 9. Substitute everything into the minus b formula. Incorporate brackets when you're doing it to ensure that all the numbers will be worked out correctly with the calculator. We get two results here to 3 decimal places. We round the third decimal to give us a 2 decimal places, and our two solutions are x is equal to 1.5. Question 4, solve the equation. Multiply in your brackets. When we multiply in 4 by 2x plus 3, we get 8x plus 12. All we need to do now is bring all the numbers to the right, bring all the letters to the left. Let's bring them over, sum them up, and we get a result of 5x is equal to minus 20. We need to solve for x only. All we need to do now is divide across by our 5, and we get the final result of 4. On to question 4. As you can see, I have some of it written out already, and we will go through it in steps. Up here we have 2x minus y is equal to 7, and x squared plus y squared is equal to 49. So we have two equations with two unknowns. What is unique about these is that one is linear and one is quadratic. Therefore, we need to make a substitution. To make the substitution, we can use the linear equation, convert y into a factor in terms of x. Now substitute this in. Okay, so when you substitute it in, you can square it out instead of y squared. And let's look at the square. This is straightforward. So we're going to split and repeat, keep it in the brackets, keep it contained, work it out in steps. So 2x by 2x minus 7 is 4x squared minus 14x. You get minus 14x over here, and then you get plus 49 by minus 7 by minus 7. Altogether, you will get 4x squared minus 28x plus 49 in the brackets. Now let's sum everything together. And we're going to get a final quadratic equation in x. As you can see, the numbers are cancelled, but we can still factor out the x. Okay, so therefore we can set either x or 5x minus 28 to 0 separately. Set x is equal to 0, and then bring across your 5. Okay, and you'll get x is equal to 0 and x is equal to 5. We're not there yet. We need to get the y values. So we need to substitute back into the linear equation. This would be a lot easier than substituting back into equation 2. So x equal to 0 in, and we will get a minus 7, and also we will get a 21 over 5 when we calculate 2 by 28 over 5 minus 7 will give you 21 over 5. Question 5. Here we're going on to functions. We have a function f of x, 3x squared minus 6x plus 7. We need to find f of 0.67 to 2 decimal places. All you need to do now is replace x with this 0.67 and use your calculator. Let's see the result. Substitute it in. We need it to 2 decimal places, so we round the 6-7 upwards so the 2 becomes a 3. Next part, find the value when f of x is equal to 4. As you can see here, f of x is equal to 4. The 4 is on the other side, so let's set it up like that. Okay, all we need to do now is bring the 4 back, as we need to solve when the equation is set to 0. Okay, these are the conditions for solving, okay, for the factoring. So let's bring it across. Okay, now we can see we've 3x squared minus 6x plus 3. We could do some factoring here. Okay, but before we do the factoring, can we simplify? Yes, we can divide across by 3. So factor out your 3. And now you can see we have a very simple quadratic. The two roots are symmetric. The minus 1 by minus 1 is plus 1. And minus 1x plus 1x will give you a minus 2x for the cross multipliers. And we have one unique solution where now we will calculate the local minimum of the function. For a maximum or minimum, if you differentiate the function and set it to 0, you can set the condition for the turning point. F of x is equal to 3x squared minus 6x plus 7. Differentiate it. The 2 multiplies by the 3 and the x becomes a 1. Do it in 2 steps and the derivative of 6x becomes minus 6. Set that to 0 for the max or the min. Now let's solve for x. This is the x coordinate of the minimum point. To get y, we need to substitute it back into f of x. You can see there 1 is replacing x. Let's get our y. Y is equal to 4. Therefore our minimum point is 1, 4. Question 6 is an arithmetic sequence question. We have 3 terms, minus 5, k and 1. First of all, we need to find k. So k will be the middle value. So we can see that there is a difference of 6 between the minus 5 and 1. Divide by 2. So we can add it to the minus 5 and we get a result of minus 2. Now we need to show that the common difference is equal to 3. We can use the third term, 1, and the common difference, okay, it will be 3. Okay. On to the part 2. T10 is going to be the 10th term of the sequence. First of all, let's get the formula for the sequence by using the log table formula, where a is the first term and d is the common difference. Substitute everything in and set n is equal to 10 once we have simplified the formula. So we have a combination here. Let's simplify it. We have 3n minus 8. Now substitute in n is equal to 10 and we will get a term value of 22. Finally, the result is 247. This usually happens in these sequences and series questions where you find the term number first, but then in the next part they will give you a result. So we're in fact working in reverse. So we're going to set the formula to the 247. Okay, so in this case we're solving for n. So just manipulate your algebra and you can see 3n is equal to 255, and I should divide in as a whole number. Okay, so n is equal to 85 is the 2021 Ordinary Level Leaving Cert Paper 1 question 6, and we're on to part B now. Again, it's an arithmetic sequence, which means it has a constant difference. A is equal to 4 and D is equal to plus 5. In this question, we need to find the sum to 50 terms. Okay, so we're using a different formula now. Let's bring it up from the log tables. So we have n over 2 bracket 2a plus n minus 1 by d. You can see we're using the a and the d again. It's the same variables as for the tn formula. Let's substitute everything in, and we are going to go to the 50 term. So n is 50 here and here. Use your calculator and we'll get a final result for the sum to 50 terms, which is 6,325. And welcome, we're on to question 7. This is a financial maths question. As you can see, I've worked out the first two parts, and let's go through it. We have three bands, 0.5, 2 and 4.5. The first question is the top rate of UCC. You can see we have the top rate, okay, threshold here along this line. This means we have to add up to 12,000 and 12, the 8,472 and the 49,560. Let's sum them all up, and this will be the threshold. On to part B, just multiply out everything, apply your rates to each band, and we get a straightforward result of €2,459.70. So far, so good. This is very straightforward. Part C is what we need to focus on most here, okay, because it's the trickiest part. Alright, so if John's annual income is 54,800, this means that he will be paying some of the 4.5% band. As if we go past the 2% band here, we will go over approximately 20,000, and then we will be paying 4.5% for the rest of the band. As we can see, the 54,800 is also less than the top of the 4.5% band. So we're going to be paying the last rate of 4.5%. So let's see how we're going to do that. So we just get the tax for the first two bands primarily, and now let's work out the 4.5% tax take. So if you look here, we have 54,500. Okay, this is his gross earnings, and then we have the earnings at which the 4.5% rate applies. So between those two limits, we will have a 4.5% band. Multiply it out, and we will get a total of €1,773.74. So have a look at that carefully, because this is where it gets tricky. Question 7, part D now. Mary pays €1,602 in USC. We need to find our total income. So let's work out some values at the start of the calculations. So we know that she's going to pay at least over 2%. So the USC up to 2% is €229.50. So if we look at the total USC, we know that after the 2%, we're going to be paying 4.5%. So let's find that amount okay, of USC paid. So the amount of USC paid is this. That would be at 4.5%, so equate this. Okay, so take your time with this and let's see exactly where this is at. So this is after the 2% and below the top of the 4.5%. Alright, so that's 4.5%. Divide by 4.5, multiply by 100, and we'll get 30,516. The earnings before the 4.5% threshold is 20,484. Add this to your 30,516, and this will be your total income. On to part E. Patrick is playing a top rate, okay, as he earns 83,000. Okay, we have a total amount in USC. So what we need to do is take the total amount of USC up to that band, okay, up to the top band, and we've got that already from part C, part B of question 7. Now let's get the actual amount of tax paid at the highest rate. So let's get the difference, and we get 10,000 or 1,036 and 48 cents. So we know that this is going to be a proportion of the difference between the top of the 4.5% band and the gross income over here. So that proportion is 8%. On to question 8 now. We have a plan with the dimensions of a cardboard box. As you can see, we have 10 here, and we also have, okay, it's a square box, so we have 10 over here as well. So we need to find L, which is the length, B the breadth, and H the height. So let's look at all of those. So first of all, if we go along the left hand length of the box, okay, we can see that the internal square part here is going to be 10 minus the 2x, okay, the 2x at either side. And again, it's very similar on the breadth, okay, and we can see there x is going to be the height as well. Okay, so you can see on the diagram, B is in the center here, and you have x on either side, so it's going to be 10 minus 2x. Okay, so length by breadth by height will give us the answer to part B. So we're going to multiply everything out. Let's put it all together. Again, you can see in the algebra, okay, we're going to have to rearrange things, and then we're going to split and repeat inside the bracket. So let's see how that goes. So 10 by the second bracket and minus 2x by the second bracket. Multiply it all out. Okay, sum the cross multipliers together in the center, and then finally multiply by x. Okay, and we have the same expression as v of x. Okay, so on to part C. Explain why a box of height 6 units cannot be made from the sheet of cardboard. Okay, so you can see here, okay, and here, okay, if we place 6 in either of those brackets, okay, either of those dimensions, we would get a negative result. Okay, so therefore it's not possible to get a box of height 6 units. Question 8, part D, E and F. We need to fill in the table at the start. So all we need to do is substitute the x values into your formula up here, and we'll get the outputs. Okay, so let's fill in our table. Okay, and we have our values, and we can plot the graph then in part E. Okay, very straightforward. Let's go on to part F now, because we need to work on the graph. Okay, so first of all we need to get the maximum, so this is going to be at the top. So let's find that point and let's go across to the maximum output, and you can see we're going to get 74 there. Okay, on to part 2. Okay, and we need to find the values of x which create a box with volume of 30 units. So this is an intermediate value. It doesn't match a volume up here, so it's between 48 and 31.5. So from the graph, go across. Okay, it's going to intersect the plot at 2 points. So there's 2 possible values, and the first one being 0.35. Okay, you need to estimate this pretty close, okay, to get the marks. Okay, and over here again you can see it's just past 3.5, so it's just marginally past, so it's 3.55. Okay, and finally find the volume of the box when x is 2.8 units. So this would be down here, x is 2.8. So again, we're going to use the graph, but we're going to work back. So we're going to go from here upwards and out, and let's see what we get. So we get 54. And finally, we're on to the last question of paper 1 of the 2021 ordinary level maths solution. Here we have the 3 patterns. All we need to do is plot the 4 patterns. So as you can see, it's increasing by 1 with the dots, and it's increasing in 2 dimensions then with the actual crosses. So the next pattern will look like this, the 4th pattern. So we need to find the formula of the number of dots. This looks very straightforward. So let's use the linear equation here. So A is equal to 1 and D is equal to 1. Okay, so substitute everything in and you're going to get your formula. Question 9, part B. We're on to a new pattern here, which is a quadratic style pattern. We're given the formula Tn is equal to n squared over 2 plus bn plus c. So we can see here we have 2 unknowns. Firstly, we need to use a substitution for n to write Tn and T2 in terms of A, B, and in terms of B and C. So we can substitute in 1. Substitute in 1 and we can get the first one. Okay, as it's T1, substitute in 1 and we get a result of T1 is equal to a half plus B plus C. So everything is brought over to the right hand side and we have a sum. Do the same for 2 and bring everything over to the right hand side, so we can state that T2 is 2 plus 2B plus C. Okay, so let's go on to part 2. Alright, so for the first pattern we have a total of 1. Okay, so T1 is equal to 1. So set this equal to 1. And now we have a first equation for solving B and C. We need to do this again for the second term, and we can see over here the output of the second term T2 is equal to 3. So let's set this equal to 3 and solve. Okay, so bring the 3 okay to the right, the 2 goes over and we get 2b plus c is equal to 1. So this is our second equation, and we're going to use these 2 equations to solve for b and c because we need 2 equations to solve for 2 unknowns. So the simultaneous equations will work out as such. Okay, we need to multiply maybe one of the lines by minus 1 to change the signs. When we do this, you can see we'll have minus b minus c is equal to minus a half. This is ideal as we can cancel the c's. So b will be equal to a half and c will be equal to 0. Part B now is the speed, distance and time question. First of all, John is walking on a circular trail. We need to find out how long it takes him to do 3 circuits of that trail. First of all, work out the perimeter. Now we need to multiply everything out for 3 cycles. Apply the speed is equal to distance over time formula. Okay, so we can see the time is distance over speed. Can interchange the speed and the time. The 6 goes below, so we'll get 9.52 divided by 6 kilometers per hour, which will give us 1.7 hours. Let's convert into minutes now. So the 0.57 here will multiply by 60. Okay, it's decimal into minutes. Okay, so now we have 34.2 minutes. So in totality, we have 1 hour. Okay, 60 plus 34 rounded. Okay, is 94 minutes. On to the next part. Okay, so Mary is increasing her rate at 15% per day. So I'm going to use this formula here. It's like compound interest, but it's going to increase the rate at 15%. And I'm going to apply this to the numbers above. So the 15% is the I. T is going to be the number of times she compounds that rate as she's increasing this per circuit. Okay, so in total she will do 4 circuits. So let's see how the values go together. So we're going to get 3 is our starting distance. Okay, 1.15 okay is the increase per lap, and we're going to apply that 4 times. Okay, so all we have to do now is work out the time, just like the last one. Divide the distance by the speed and work out your minutes. To the last part of question 9 in the 2021 Leaving Cert Ordinary Level Maths paper. What we have here is John and Mary travelling in opposite directions. We need to find how long it will take for John, okay, how long he will travel before they meet again. Okay, so he's going at the 6 kilometers per hour rate. First of all, let's find out the time they will meet. Okay, so effectively, if they're going 4 plus 6, this will give us a total of 10. Okay, because they're going towards each other. Okay, so this means that the time it will take will be the distance over the combined rate, which is going to be 0.314 hours. John's speed is 6 kilometers per hour. Distance is equal to speed by time multiplied out, and we'll get a total of 1,885 meters. So well done, and